In this video, I want to introduce the idea of recursive data. So we've already seen the idea of having a function or a method that can call itself. This was very useful. It does solve kind of some unique problems. So here's a related thought. What if I made a class refer to itself? For example, class node contains a variable of type node and is called next. So can I do this? If I put this into Java, will it work? Well, it will. This is what we call a self-referential class. It's a class that refers to itself, right? This is related to the idea of recursion, right? Solving a problem in terms of itself. Now we're constructing something in terms of itself, right? A node is built from a node, right? Self-referential, right? Recursion, think about it. Okay, so this is our fundamental idea here, right? Now the general term for something inside of a linked list is going to be node, right? So in my linked list here, right, this thing over here, each of these are nodes. The way I get that, well, the way I get the name for that, right, linked list comes from the way things are put together. Notice I have basically my node class just storing another node. That's a link, right? So this node is linked to another one. This node is linked to another one, right? That's what this is doing. This next variable represents a linkage from one node to another node that follows it, okay? That's where the name comes from, linked list node. The linked lists are, the nodes are self-referential, right, and they're linked to other ones, right? As a whole, when I put them together and I link them one after another, that forms a linked list, right? Sometimes we'll just say list. All right, so the whole thing's recursive. And also, right, we have to also remember what makes this possible is the fact that Java stores objects as references. So remember, right, that when you have object types, right, an object type variable in Java, right, it doesn't store that variable itself, it doesn't store that value itself, rather it stores a reference to where you can go find it, right, which is important here. That's what gives us these arrows, right? So a node doesn't store another node, it stores a reference to where it can go find another node, right? That's the way we want to think about this, right? So inside of node, right, it has basically the address, right, some magic number of where it can go to find something else, something new. So that's how this thing is put together, right? We want to be careful here, right? We don't want to say that a node contains another node, right? That's a different statement, right? It's different to say that a node contains a node versus a node contains a reference to another node, right? Those are very different things, right? Because a node can't contain a node. If a node contains a node, then the node, well, how do you get to the bottom, right? It's like those nesting dolls, right? You put something inside, put something inside. They have to get smaller. You can't put something that's the same inside of itself. You'll have basically no stopping point if you try to do that, right? So you can't have a nodes containing nodes. Imagine asking yourself the following question. Assuming you had a node that contained another node, how could I figure out the size of that node? Well, to find out the size of a node, you need to add up its size plus the size of the thing it contains. Well, it contains another node. So how much does that store? You have to ask the same question again and again and again, and you never get an answer at the end of the day, okay? So you cannot have a node that stores another node. Rather, you have a node that stores the address of another node because the address is really just an integer, right? So it's actually closed. Even though it looks here like it's the same thing, right? You're storing literally, you're storing just a link, right? And that, is really just a number, which is much more, tractable, right? We can figure out the size of a number. We can just record that address. We can tell where to go to get more of this node, right? That's a much more reasonable thing. All right, so this is the idea, right? Basically, you're taking recursion, now applying it in the structural sense to have recursive data. We need to build on this a little bit, though, in order to actually do work, right? Because right now we just have things linked together, which is cool, but we need to actually store data, like, for example, the data in our stack that we've been talking about. So what do? Just add another variable, right? So int data. So we add basically something along for the ride, right? So we have our pointer to get to some more thing, right? Get to another node, to get to another bit of data. But in addition to that, we also have our variable there, right? That stores the actual data itself, right? So the data that we want to have in each of the nodes, right? So now you have two things. And this is kind of the basic component of nodes in general, right? Is to have a piece of data and then the node, right? Those are the two things that we need. Once we do that, we have this, again, this linked structure forms again, right? The next is basically taking care of a little arrow here. And then our keyword data, right, that variable there, well, it's not a keyword, our variable data there, right, is what stores this, 1, 2, 3. And they kind of come along for the ride with the different pointers to lead me to new nodes. All right, so this is the very simplest node we could construct. This is a very basic idea. This is another way to structure data. This is what we're going to use, right, to do kind of an improved implementation of Stack. All right, so that's all I got for you guys here in this video. And in the next video, we'll take a look at arrays versus lists and some of the performance considerations that emerge. It'll be a topic you basically will see over and over again, right? Because it's very important, right? How do I choose what to use? For now, we'll stick with a list, right, when we do that stack, but it's important to know how they differ in terms of performance. So I'll see you guys in that video.